Hello everybody, how is everyone doing now? Had a good conference? Good. Thank you. My name is Gopi Kumar, I'm a program manager in the data science team. With me I have...
Jakob Spolstra, I'm here, I head up the data science team.
I don't have microphone, so my name is Hang. I'm a senior data scientist.
We'll give Hang a microphone soon.
Thank you. Before we proceed, I just wanted to kind of get a quick poll. How many of you work within a data science team? Okay. How many of you are data scientists? How many of you are software engineers? Okay, very good. Okay. A pretty good mix of data scientists and software engineers. So our talk is about data science process, and essentially I think our conjecture is, okay, like data science just doesn't happen. It needs some kind of a process. So I'm going to be talking about kind of the motivations for that. So this is really a very exciting time to be in the data science field. I think like several major trends are kind of coming together, and then it's making like kind of like really very exciting. One of them is the big data and IoT, and second is cloud, and then the last is intelligence. Let me explain. So today, like with the availability of cheap computing, like pretty much anything can be connected to the internet. They're all kind of generating data. So today, like your refrigerators can have computation power, and they can be connected to internet. You yourself are connected to internet with your wearables. So there's going to be a kind of a lot of data that's kind of coming in. But when you have all this data, you need some place in order to kind of process and store it. So the cloud is where that it kind of comes in, where it allows you to process massive amount of data and then able to store it. And lastly, just having all this data is not enough. Okay, you need some kind of an intelligence to really make sense of all the data, so you're not really drowning in data. So this is where intelligence kind of really comes in. And so together, all these things are creating what we call as the fourth industrial revolution. So we had several revolutions in the past, and something with the data and the analytics and the big data and the cloud. So we are seeing the ushering of the fourth industrial revolution. So before we kind of go into what this really means, I think let's try to kind of quantify like what this revolution is kind of going to bring in. So Microsoft and IDC kind of did a survey, a study. And they said, okay, this opportunity is really even bigger than what many of you would think. So it's almost like in a 4-year period, it's about $1.6 trillion. And this is called as a data dividend. So this is a difference between companies who are using data effectively and companies which are not using data effectively. So this 1.6 trillion really comes from like the cost savings, additional revenue, increased productivity. So any number of these things, so you kind of combine them. So you're looking at like about the data dividend that companies that really are able to utilize data effectively. And how are they doing this today? The companies that are doing it effectively, they're able to use like diverse set of data. So not just like your relational data or CSV type data. So now we are able to use a rich set of data from like IoT, like multimedia, images. And then you're using like new analytics techniques, and then really providing access to more people access to the data. So you are democratizing the access to data, which is making kind of companies more productive, and kind of really realize that data dividend that I talked about. And you are doing all these things at the speed, at like internet speed and at cloud speed. So how are people using this technology? So this has revolutionized how people are building applications. So traditionally applications were based on like really static rules, and then like everything was kind of all predefined, and there was limited ability to kind of adapt it to change in behaviors. So now intelligent applications are kind of infused with more data and then intelligence. So they can be so they can adapt to kind of changes in conditions. For example, like instead of having a static set of recommendations, now you can actually have a machine learning model that can actually provide you recommendation based on incoming data, and that keeps changing. Okay, like as new fads coming in or new memes kind of show up on the internet. So this is able to kind of adapt to some of those trends more effectively. So here are some examples where we see that okay, people are effectively using like recommendations, predictive maintenance, churn detection, and in the CRM domain, like you can take your prospects and then score your prospects, so you know like who are the kind of high priority customers you can really kind of pay more attention to and really improve your business. Having said that, I think there's still some sobering statistics here. So the opportunity is really huge, but I think the number of projects that are really considered successful is still a pretty small part. So only about 27% of the projects are considered successful. Successful meaning they meet the expectations and the goals that were set. And then only 13% of the organization have really taken their models or their implementations and then gone like really production. And only 8% really exceeded the expectations. And the other thing is only 17% of the companies in that survey really had a well-developed data science program, though I think 80% would like to kind of create such a program in future. So let's look at what some of the challenges that are there. So in the same survey, they also kind of looked at what are some of the challenges that are there. So I won't read all this one, but I think there's a combination of technical and the non-technical business type process type issues. So obviously on the technical side, I think there's a lot of change going on with like newer techniques and better algorithms that are kind of coming in, kind of addressing those. Our focus is mostly on kind of some of the process-oriented issues that are actually hindering the successful implementation of data science programs. So these two, like of the top three, you see like two of them are really related to kind of process-oriented issues where I think there is a lack of a clear business case or funding or sponsorship. And then there's ineffective coordination between teams. So I think so these are the areas that we kind of want to focus on. So if you look at a typical data science program, you see that you might have seen this Venn diagram. So data science is really at the intersection of hacking or computer skills, domain expertise, and math and stats knowledge. And when people start hiring for somebody who has all these three, I think usually it's been a pretty difficult task. So what we see more commonly is I think people are building a cross-functional team with kind of complementary skills. So they bring in people with like hacking skills and substantive experience, and then another person with the math and stats knowledge and some domain knowledge, for example. For example, I myself would put myself in the purple zone. I'm in the danger zone because I don't have a deep enough mathematics and statistics background, whereas my colleagues here, I think they are very deep into math and statistics, so we kind of complement each other in teams. And this is probably what you would see. In fact, when I asked the initial poll, there's a combination of like software engineers and data scientists who are kind of working together on these initiatives. Another major change, I think, is also like previously when you do data science, there's like a lot of ad hoc analysis, and I think there was a manual step to go into kind of a production. Or sometimes analysis ended with kind of a one-off type analysis. Now more and more analysis leads to like data products and intelligent applications that we just spoke about. So here is, I don't know, people are making some kind of a transition, and not all these transitions go right. So we have a citizen data science, and I think he was a citizen pilot before. So we have looked at kind of the benefits and some of the challenges that we have in implementing successful data science programs. In spirit of the election season, data science is going to be huge, and we are going to make data science great again.
It's going to be huge. All right. So Jakob Spoelstra here. Like I mentioned previously, I head up a data science team, and I actually came from a consulting type organization as well, where we had data science teams there as well. And you know, data science is a fairly new term, and when people ask me what is data science, I always say data science is where machine learning meets the real world, right? As you're not a statistician or you're doing machine learning, but data science is about bringing that together and actually building a business application, and more deploying that as either a microservice or as some part of a line of business application, right? So it's about building something that's going to be a service or a product, and it's no longer also a single single sport, right? It's an individual sport. Data science became a team sport, and it's not just data scientists. There's a fairly large team involved. And when you have that, you start to need some kind of coordination and some way to organize things. So, like I said, I was in consulting type organizations, and then when I came to Microsoft, this is the landscape that we have, right? The first thing is that we have global teams. We have about 6 locations spread, across all time zones, where there are teams of data science that work and often have to work together, right, in these geographic locations. Like everybody else, we're continuously hiring people. So you're continuously bringing people in from various different backgrounds, some out of school, some kind of, from a prior experience, but to come into these teams with their different experience, different ways of working, and they all have to work together to deliver a product, right? And then data science teams, like we do, and I suppose you do the same, is we're not working in a specific pipeline to deliver the same thing over and over. We work with different clients. They have different kind of problems that we have to deal with all the time. But I'm just curious, as a show of hand, how many people have similar types of environments that you work in? Just as a show of hand. All right. So let's say a majority of the audience here, right, have that environment. All right. And then what are we trying to do, right? The first thing is, as a team, we're trying to enforce quality. And for data science, what does quality mean? It means that it's every project that you've undertaken, we want to make sure that you've looked at the data the same way, you've checked the data, the statistics of the data, that you generate a report in the same way that has all the components in it that we want from that. When you're doing a model, we want to know that you've done your features, you've analyzed your features, you've tested your model, you've actually done the proper metrics and when you're evaluating a model, right? So consistency in that work product, right? The second thing is organization. We want to be able to see, we have lots of people working on different things. They work in different environments. They might be working on VMs. They might be working on, on laptops everywhere. Where does all this work product go, right? Where does the code go? Where does the documentation go? Where do I find what's going on with the current project when you have lots of people working on this, right? How do you bring everything together so you know where all your work product is organized? In a similar vein is when you collaborate. When you have multiple people working on projects, again, how do you make sure that you can tell that they're collaborating efficiently, that when someone updates a particular script in a pipeline for doing some data processing, that this gets transferred to his teammate who might be in a different location, that everybody stays on the same page when they're working, that they, as they do in these collaboration. A fourth challenge that we find often is this idea of knowledge accumulation, right? As we're building a team, one of the key things we want to do is we want to get this institutional knowledge to grow. As you're doing more projects and you're figuring out shortcuts and someone has a new way for slicing a file up or for joining 2 large files or for doing a particular statistical analysis on the data, we want to share that, right? And I don't know about you, but often for me the case it's like, hey, Hung, email me that script you just wrote that I heard about yesterday, right? And he emails you the Python code. Or send me an example of that last report you did, right? How do you make sure that this knowledge accumulates and that you can continue reusing it? And then the final goal is, as we call this, agility, is the net product of the teams gaining experience should be that they become faster, that they become more efficient in delivering these products, right? So we want to capture all these things so the teams become better at it. All right. So how did we deal with this? Now the one thing is, data science is not software engineering. There's a different thing. But as we're delivering products and these output of data science as a service, it's starting to look more like a software engineering product, right? And software engineering has come through a long evolution of figuring out how to become more efficient and work better. So we can learn from them, especially in the software engineering process. So here's a good quote from Edward Deming. For you guys who don't know him, he's the guy who is credited with the sampling techniques used in the census, also for doing a lot of work in statistical process control and bringing that to manufacturing, and actually credited with the whole Japanese miracle in the 50s, 60s. And he says, if you can't describe what you're doing as a process, you don't know what you're doing. Right? So it's important to kind of capture your knowledge as a process. Okay, so what is a process? The definition here is it specifies a detailed sequence of activities necessary to perform a specific business task, right? So my slightly abridged version. The important thing is that once you have a process, and it's a documented process, it gives you a mechanism to improve on what you're doing, right? So you can measure specific inefficiencies in this process and improve that piece, and then hopefully next time you perform the same action, it'll be slightly better than before, right? So it's really a mechanism for you. It's like version control for your work product or your work methodology. That's really what we want to do, right? And it allows you to establish these best practices, and of course when you've established best practices, this is how you bring on new people on a team. This is how you train your team, and that training sticks in terms of what they do. Okay, so here's a sketch, and we don't go through all the details of it, of how software engineering came about with the software engineering process that they currently use. So software engineering, in the early years, like 50s, 60s, was also very much an individual sport, right? You either had some kind of specification that you then went and you coded up in a machine, right? And that was your software process. But it, through the years, evolved, and especially as software became more complex and more people got involved, and it got, became these huge projects, they developed very specific processes, and it evolved, from the waterfall, very linear process, into more of a, the current agile systems that are more kind of like sprint-based, where you constantly have backlogs that you work against, right? So what we're going to try and advocate is taking some of this and say, can we do data science in a similar way, and can we benefit from it in that sense? Okay, so the question is, well, I usually say, like, as we're doing data science, do people actually have a current process? This is from a KD Nuggets poll, and I must say I was kind of surprised to see this. The few takeaways here, there are two things. The one is that nobody, let's see, where is the pointer here? Nobody says they don't use a process, so I'm not sure if that's completely true, but it seems like everybody has at least something that they describe as a process that they use, right? CrispDM is still and we'll talk about that in a second, it's still the most popular, and then, the second most popular is my own process. Okay, so this is like, I have some system of working, right? So so if you look at, right, so this is CrispDM. If people are not familiar with it, it essentially describes the life cycle of a data science project. And it has the, kind of fairly intuitive phases of understanding the business, the data, prepping it, modeling, evaluation. It highlights the fact that a lot of these are very iterative, that you go back and forth between the understanding data and the business, and then preparing data and modeling and all those. And it's one that it's hard to argue against it, right? That is more or less the stuff you need to do to do a data science process. But it's also very general, so it's kind of at a high level describes what you do, and you can go to someone and say, okay, I want you to follow this process when you develop a project, but it's not very prescriptive, and okay, exactly what should I do and what should I produce as I go through this process. All right, KDD has a similar process, but I think it essentially describes the same thing. All right, so what we did is we said, all right, at Microsoft, since we have all these challenges, we kind of evolved the process that's been working very well and made, be kind of efficient in how we do things. And that's what we want to share with you. And essentially, it has these four components. So the first is that we look at, when we track projects, and we kind of, we have lots of projects going on at any given time, and we report on the status of these projects. Kind of what is it really what is the life cycle status that we want to report on that makes sense for us to describe what's going on in a project. The second is we said, all right, we want to kind of enforce quality by providing templates for what should you produce at various stages when you follow this process. I always think of processes, for instance, if there's a certain process for doing HR for hiring, that if someone followed the process, they did a pre-screen, they did a phone interview, they wrote a report on what the phone interview did. Similar for data science, we want you to document that you did each of the steps, and you have a standardized report you produce at the end of this. The second is that we're part of the Azure group. A lot of our work happens on VMs. There's a data science VM, I think you've heard of before, that creates a virtual environment. So these days the environment is that there's data assets and there's compute assets that are almost ephemeral. You pop them up for a specific piece of work, you bring them down again. How do you keep track of all these resources that are around? And the last thing is, we want to have a way in which you can capture these utilities. So there are certain utilities for doing data analysis, for connecting data sources to VMs, for all the things that you have to do routinely and repeatedly. We want to capture these utilities and version control them so you can reuse them easily. All right. So let's go through each one of the fours quickly, and then we're going to get to actually show you what these things look like in reality. The first thing is the life cycle, and you'll recognize similar concepts to what we have in the CRISP PM, but what we basically track is essentially 4 stages. The first is still our business understanding. We call it kind of scoping. You're talking to someone, you're figuring out what exactly are we trying to do here. Then there's a phase of data, getting data, right? And when we talk about getting data, this involves everything from figuring out what data is available, getting some initial data, studying it, doing all the back and forth that you have to do with the data acquisition. Usually at some point then you're kind of more or less satisfied, I have all the data I need for my project. Then you go over and you're in a modeling phase, right? And modeling, and we encapsulate there's the interaction between doing feature engineering, model evaluation is such a close loop that we essentially just bundle those as I'm doing modeling. Of course, there's some back and forth. You might go back to data. And then finally, you're in some kind of a deployment stage. Again, this is where we're talking about data science as delivering either a web service, some kind of a microservice. So you go over from, okay, we're at some point satisfied with our model, and now we're figuring out how do we connect this thing up to be connected in the real world. So those are essentially the life cycle stages that we track. The next thing, and this is a bit of an eye chart, but I want to kind of illustrate to you just more or less what the phases are. We actually document a process diagram, and it has a few major things to look at. The one is that and vertically you see the various, there we go, right? You see the various phases that we're in. So we're in business, data, modeling, deployment. And then we define swim lanes for certain people who do certain things. For instance, you have a project lead who's more or less concerned with setting up the environment, making sure that we're, that the team is ready to start the work. You have project managers and solution architects who work with defining a charter for your project, starting to work on the solution architect, and then data scientists or multiple of these who actually work in terms of the data ingest and modeling. And you'll notice for each one of these, there's specific tasks, and they're specific. The green indicates specific artifacts that they produce when they go through these phases, right? So everyone has certain swim lanes. In some cases, this might be the same person, right, if it's a smaller team. But there are specifically defined things that you have to do with, what do you do when you're in this phase? What do you produce as you're exiting this phase? All right. When I mentioned in order for the consistency, we have templates. So these templates are things that live in repositories, and they help you, similar to what in a software project, nobody these days starts with a blank screen. You start with a template that has a lot of the basic plumbing already coded for you. So we try and do the same for data science. We produce a specific directory structure of where you're going to find various files that you're going to produce and artifacts. And for each specifically, say for the documents, these are templates that have like almost checklist-like questions in there. The sections are predefined for you. There's questions that you need to answer to fill out this document. So it makes it much easier, right? It's not trying to think of like, okay, what do I write here? You basically you go through it, you answer the questions, and that gives you the right document. And then in terms of utilities, these are focused on, some of the areas we focus on are things that you do standard, like data analysis and data understanding. And we'll show you some demos of that as soon as we're done. Okay. So I mentioned that we work, so from the outset, we're designing this for teams who work in these distributed environments, right? So as you see on this graph here, the idea is that there's, similar to software projects, the main artifacts live in a repository, in this case a Git repository. And you'll see in the demo what we've done is we've used Visual Studio Team Services. For those of you who haven't looked at that, so it's worth taking a look at this. It gives you a very good environment for managing these repositories, also for tracking work items and therefore. So the repositories essentially keep the artifacts of your job, and also as well as the templates that you instantiate when you start a new project. Concept then is that for any given project, any data scientist spins up as many VMs as he needs. Any project has some data artifacts that are simply being shared and connected to by the VMs. And any project might have multiple people working on it, and you might have multiple projects done on the same VM. So the whole idea is that compute is something you provision for yourself to work on a project. And similar to a software project, every data scientist has a checked out copy of this repository, and he's working on this similar to what he would have done on a software project, right? You're writing your code locally, you're executing, you're checking it back in, and this code might run and make changes on a shared data artifact, right? So what the process allows you to do is we provide some utilities for connecting to these, for checking in and keeping track of what you're doing. All right, and then, this is just a little cartoon, but the reason we do this is that as we're doing project after project, we're starting to see some improvement in metrics, right? We look at, how long does a project run from begin to end? How long does it take from when you get the data until you have your first baseline model built, right? So that's the whole goal of this, is to really improve over time how we perform as a data science team. Okay, so with that introduction, we're now actually going to take you through some examples and just show you, our implementation of how we do this and what it looks like in Microsoft. And Hang will do that.
Thank you, Jakob. I hope just now my colleagues, Gopi and Jakob, have provided you enough background what problems we are addressing in the team data science process and what we are proposing to implement the team data science process to make your data science organization more productive. Now I'm here to tell you what exactly we are doing at Microsoft within our data science organization in order to achieve productivity and efficiency. At Microsoft, we use the data science virtual machine as our fundamental computational platform. We use Visual Studio Team Services for version control and for work item tracking and Scrum planning. We also develop a set of utilities to share across the teams and within each team to make each team and the entire organization more productive. We do not have to reinvent the wheels if those utilities mostly are very useful, very common in multiple projects. So the data science VM, currently we have released the data science VM in two operating systems. One is the Windows system, one is the Linux system. The data science VM comes by default with a rich set of utilities and useful tools for data science. For example, it comes with the Anaconda Python. It has the Microsoft R Open. It has the Microsoft R Server developer version. And it also has a couple of cloud resource management tools such as Azure Storage Explorer, AZ Copy, something like for you to very easily communicate with the Azure cloud. It saves your time on setting up your computing environment. Previously, you have to say for every employee, you might have to spend a lot of time, money on setting up their laptop, or they have to do that by themselves in order to get this environment. For DSVM, you get almost everything by default. The data science VM, we also use DSVM as a shared resource within the team. For example, in the just past summer, I have a summer intern. On day one, he joined my team. I assigned him a data science VM. So he used this VM to carry on his summer intern project. So once he left a couple of weeks ago, I easily recycle this virtual machine to save on my budget. I don't have to worry about anything to recycle in this virtual machine because all his work has been checked in to the Git repository. So everything is checked in, so I don't have to worry anything. So it saves you budget on getting the computers for your team. We also use DSVM as an anchor point to hook up with a lot of Azure resources. So for example, we can mount a Azure file storage easily on a data science virtual machine so that everyone within have that file share storage mounted can easily access to the same copy of the data. So we use Visual Studio Team Services for work item tracking and agile planning. Here we are borrowing some concepts from the software development. But we use it slightly differently. Here we name a feature as a project, and the story is a stage in the end-to-end process of data science project. For example, here in this snapshot, I'm showing you about 5 to 6 stories of this project, which is the Starbucks demand forecasting. That's a virtual project. We have stories such as do the data exploration, get the data, do the feature engineering, modeling, etc. And under each story, you can have multiple tasks. Each task is a specific coding activity or documentation activity. After you complete all the tasks within a story, you have this story done. And the iteration, usually the iteration is a 2-week sprint planning. So if you look at this screen, you can see that you can have the iteration 1, that's the current iteration, iteration 2. You can define what's the starting time and ending time of iteration, and you can assign all these tickets, work items into each iteration, so you can easily plan your iteration. So your data science projects can be carried out in a planned way.
It might be worthwhile to ask us is, how many people are familiar with the Agile and Scrum methodology? Good. And how many people actually use this in their data science execution? All right, so it's actually it's a fair amount, but not as many. Perfect.
Okay. So another feature of Visual Studio Team Services I want to really highlight in the team data science process is its capability to link the work item with a Git branch. So usually in many companies, they use 2 independent systems, one for the version control, such as the Git or GitHub. Another one is for work item tracking, such as Jira. But the difficulty here is that if you use 2 independent systems, it might not be so easy for you to connect your work item with your Git activity. So here in VSTS, you have that capability by default. For example, here you can easily do this by, say, if you click, open a work item, the detail page, there is a link section here for allowing you to add a link to this ticket, and you can either create a new branch for this ticket, or you can link this ticket to an existing branch. So you can do, after you create, for example, if you create a new branch, you can check out this new branch and do some work items there and check out. And after that, after you push to this branch, you can come to the VSTS to request a code review. The code review now becomes more and more important for data scientists. The reason is that previously in history, data science work in the backend. They do a lot of ad hoc activity. They don't worry so much about their activity is going to break in the product system, because between data scientists and the product line, there is a software engineer in the middle, right? So they don't worry so much. But now, as the new trend is that the data scientists pushing forward to the product line. For example, the Azure machine learning now is enabling data scientists to directly operationalize their product, their model, into a web service. And that web service is immediately integrated into product. So the data scientists have to now needs this kind of code review process to make sure that their activity does not break the product system. So for example, here you can create a pull request, and after you make a pull request, you can request some of your reviewers, for example, your project lead or your team lead to review that. And then after that, if your reviewer log in, he can approve and complete this merging process. Okay. Productivity tools. So, for example, if you are in a demand forecasting team, you are working on a lot of the time series modeling stuff. And your team might have already, when you are doing some kind of early stage project, you have developed some R script or Python script to generate those kind of common features for your demand forecasting. So if you feel these kind of artifacts are going to be useful for many other projects, I will recommend you that you generalize those scripts into some utilities and share with your team. So this is what we're doing here. We developed 2 utilities, and we publish these utilities into the public GitHub. The first utility I'm going to show you a demo later on is called it is Shiny-based, it's in R. It's Shiny-based interactive data exploration, analysis, and reporting. We call it IDEA. The second utility is the automated modeling and reporting. Here, this one is just a snapshot. So basically, the IDEA utility is guiding you step by step from simple to complex, from single variable to multiple variable. In a guided mode, you explore the data and you generate the report as you've seen during the interactive stage. For example, here, this is in the beginning, you get a peek of the data by printing out the top 10 variables. You can change the number of top 10 rows. You can change the number of rows by inputting some artificial number you want. After that, we are providing you the capability to explore the individual variables. We plot the histogram, the density plot, and we also conduct the statistical testing to test whether this variable is normal or not. After that, variable ranking. So in machine learning, if you have a lot of variables, you are always interested in to know which variables are mostly correlated or associated with my target variable. So here we provide you to say, for example, here I'm using the NYC tax data. The task here is a classification task. It is determining whether a trip is tipped or not. So we are doing variable ranking. We rank the numerical variables and categorical variables separately. So this is the variable ranking bar charts. If you look at this one, you can see that there is one variable very highly correlated with the target variable. So the variable column name is called payment type. So this morning, Dr. Tufte mentioned that when you see something, you really need to have a pair of thinking eyes. So is this variable really some good predictor, or is really just a target leaker? So this is the place where you need to consult with your data expert to understand really what's the process of generating the data. So if you think deeper, actually this kind of observation is revealing the human nature. So for a ride, when the rider is paying by credit card, the driver has no way to hide this income. So he has to report this as a trip is tipped. But if a rider is paying by cash, very likely the driver will hide this kind of income for tax benefit. So this is really something, a good example. This tool is going to help you to identify target leaker. Another example is that our London team adopts this tool in some real project. In a project which is in healthcare to predict the readmission. The target is readmission. But in his feature set, he has several other variables named as such as readmission type, readmission location, for example. So he runs this tool. All those variables started with the variable name started with readmission, shows up to be the very, very top in the variable ranking. So this instantly reminds him, okay, I'm really not getting a good set of predictors. Actually, I'm getting a set of target leakers. So this is the one useful case of this tool is giving you is the benefit you can get. Another thing this tool is going to help you to get is the insight to the data. So this is the data. This picture shows the projection of the high dimension numerical variable into low dimension principal component space in 3-dimensional space. So you can see that after you project the high dimensional matrix into lower dimension, you might be able to visualize some useful pattern in your data. For example, if you want to do some customer segmentation, you might be able to reveal the clustering pattern in your customer group. So another benefit of data science team managers can get after they adopt the TDSP is the convenience to monitor and to track the status of the projects. So think about this. If you are the data science team manager, after the project kick off, you want to know what is happening in the project. VSTS allows you to easily connect, you easily build a Power BI dashboard from the VSTS server. So here I'm showing you two examples. This report shows the Git commit activity your team members have done in the past time to the Git repositories. You can easily slice dice by the committer, by the time, and by the project. This is the one to showing you how do you track the work items. You can easily track, such as the number of stories, number of tasks, number of features in your team, and also group by the number of the users and color by the different state of this work items. Now, I'm going to show you some live demo. Let me switch to the. So first, I'm going to show you the project template. Okay, I need to.
That's okay.
Okay, good. Yeah. So this is project charter template. In this project charter, we are asking you a set of questions for the project lead to answer. During the process of seeking for the answers to these questions, and after you filled in, you are setting up the project, such as you are setting up the business background, the scope, what should be done, what should be the timeline, what should be the human resource you want to invest, what should be your plan for the consumption, and what should be the final architecture design. Yeah. So another thing I want to show you is about the how to connect a Git work item in VSTS to a Git branch. If you double-click this item here, there is a task assigned to me to do another round of data exploration using the IDEA tool. So I can come here and create and add a link, create a new branch. And I can create a branch, say IDEA branch 2. For example, I want to base this branch from master branch and based on the repository adult income classification. Then I can create a branch. So your branch is created, and you can check out the branch and work on your branch and then check in. So that's the process. Now if I come back to this one, I can show you some example after you have done on a branch what you can get. So here, for example, data exploration, I have this one. This ticket is connected with a branch, and that branch has been merged to my master. If I double-click, if I go to the history, I can see exactly what has been done for this ticket. You can see these are the reports I have checked in. Those are the image files. And later I'm going to show you the exact tool idea to do the data exploration. Now, this is a fun demo of the data exploration. Now, this is R-based utility. We share this everything in the GitHub. You can check in and run in your RStudio. Now, if you open this run idea.r file, you can just source it.
And you might want to mention, so the idea is that these, so what you get is the process is there are these repositories that have utilities and that have templates, right? So you start a project, you have all these on your virtual machine. So everyone has access to all these shared utilities. And this is one of those utilities that you typically access, right?
Yeah. So the first thing you are going to be asked, prompt to remind you that in the next step, you need to select a YAML file. The YAML file is defining let me open this one, is defining where's your data and what's the format of your data. All the other fields, such as categorical columns and the numerical columns, you can forget about them. If you are not familiar with your data, you don't know which columns are numerical, which columns are categorical.
Or just press Control 1 to zoom.
Is this better? Yeah, if you leave those two fields not in your YAML file, the software, the IDEA will automatically detect the type of the variable. And also another field you need to have is the R log file path. We need this file to store the R script during the interactive process that you can click a button to output the R code that is generating what you see in the tool to this R log. Later on, when you click a button of generating the final report, this file is going to be executed. Let me show you here. Now, if I double click, okay. Can you guys see in the back?
Use Control 1 to zoom.
Okay. Now let me go very, very quickly. So in the data summary, you can see the print the top 10 rows. You can change to top 5 rows. It will just print the top 5 rows. You see? Now if you want this one to be in your report, you click Export button. Now let me quickly jump to the, say the variable ranking, for example. Now I want to rank the top 5 variables for numerical and categorical with the target label. Label is over 50K. This is adult census data. You click Go. Okay, it is printing out the bar chart of this variable ranking. Now if you want this one to be in your report, you click Export. Now another thing I want to show you is the project numerical variables to principal components. You can select which ones to show on it to be your principal axis. You can select 3, and you can see here. This is some pattern you might not be aware of before. So you see that it clearly shows looks like 3 clusters, and we also color these clusters based on the target label. You can see easily, okay, if one cluster is dominated by one cluster label, you might be able to, by target label, you might be able to see, okay, there might be something specific for that group of users. You can export this one to your report. And we also allow you to export project to 3-dimension space. And as you might imagine, when you project to 3-dimension space, if you change the viewing angle, you might view different clustering pattern in your data. For example, here, if I scroll the bar a little bit this side, yeah, you see here, you have the clustering pattern visualized in 3-dimension space. You can click this export to your R file and then click the generate report. The report will be generated in process, and it will complete in a couple minutes. Not in a couple minutes, just less than 1 minute. I'll show you later. Okay, while it is running, let me switch back to the talk. So one last slide from me. Okay. Yeah, so recap of the IDEA. IDEA is a tool for data quality assessment, data relevance assessment, and assessment of the challenge level of the machine learning task. It is helping you to review the hidden patterns of the data and help you to get insight from the data. It can generate a data report automatically as you explore interactively. But, let's see. But, what if your data is not relevant? So here's a couple of tips. The number 1 tip is that do not complain to your client who provided you the data. Tip 2 is that do not yell at the machines that generated the data. Tip 3, I borrowed this idea from today's keynote speech. To learn about the physical process as a whole, directly observe how the original measurements are made in the field. This is from the Edward Tufte this morning.
All right, I think we have about a minute left. So this talk was meant to just introduce you to kind of like how we run data science projects, right? With the integration with Visual Studio, with the tools and the stuff that we have. Basically, what we found the benefits there to be is that, both for kind of like the management, you get the organization, standardization, versioning. So basically, becoming a more efficient, higher quality producing data science team. And then, also on an individual contributor side, right? The fact that you have these tools that you saw for data exploration, right? We're trying to make your life easier, and we're trying to get people to as they adopt this, to start contributing and also collaborate more efficiently. So basically what we're doing here is, we've got all these assets that you just saw. They are on GitHub. So you can go there, you can get to the basic templates that we have. There's documentation that shows you the instructions. How do you go about adopting this for yourself? And what we'd like people to do is, this is really meant to be a community type effort, right? We'd love people to go there, to go look at those repositories, start using this as a way that you operate or run your projects, or if it works for you. But then contribute back, right? If you can give us improvements on tools, if you have a specific tool if you have templates, you can improve our templates for documents, submit those, right? We want the community to start standardizing and improving this whole process. So with that, thank you very much. We have a few seconds, or I think 50 seconds left for questions. Happy to answer questions or anything that you want to ask. Yes, please.
So I'm going to assume that your process, you have not gotten to a point where you are looking at 10, 12, 15 models that are in production, and you're tracking them and trying to see which ones need tuning, which one may need some oversight, and so the decisions that are being made, whether they're still valuable decisions from an operational standpoint. So you do not, this is more like building. The process of governance, audit control, and tuning is outside of the scope of this methodology.
All right, so the question is about the governance and of production systems as they are in there, right? You're right in the sense that the processes we explained it here is really aimed at this development process. In the final process flow diagram, we do have a state where we call operationalization, and that is where we kind of bundle all the activities to do with exactly what you're mentioning, right? So monitoring in production systems and going through the upgrade of that. But it's a good point, right? In terms of the versioning of models and the recontrol. Right now we view that almost like an outer loop. So maybe say if you do a periodic update of a model, you'll kind of re-engage and go through that same process again.
One thing you'll see in the document repository is, I think, all your experiments that you tried, every model directory is going to have like every experiment you tried will be like a separate directory, and then you can actually compare the models, and then the final model, how you actually came up with the final model. So that tracing is there, and then obviously we need to kind of work a little bit more on the. Obviously, we're using a version control system, so it's possible, but I think we need to probably make some enhancements.
So the iterations for models, we do capture that, but I mean, I know what you mean. It's like there's a production system and there's a routine, ongoing product. Yes, up here. Yeah.
Thousands of packages being added to.
That's okay. Please go ahead. Please go ahead.
Use the mic, please.
Yeah. Thank you.
Thank you.
With the thousands of packages that are being added to R right now, do you have any process for checking which ones are numerically stable and valid so that they can be ingested for production use, or are you just hoping that if it's committed to CRAN, it's good?
All right, in terms of the which packages we use, again, I think that's maybe slightly outside the scope of this process. I mean, as you're developing models, I think what we can do is you can capture those that you've investigated and you've deemed appropriate for the work that you do, and capture that maybe as your best practices. So adopting this process, one of the things we want to do here is you want to capture that information. So if you want to capture that in your documentation, right, as a checklist of, okay, has this package been okayed by our internal process? If you maintain some list somewhere, This will give you a method whereby you can maintain such a list and include that checklist in your, so you know that everything that gets produced, someone has at least checked it and got that approval, right? How you do it, that's up to you, but this allows you to document that process.
Yeah, if you look at the model report, we are providing a template for you to fill in for the model report. In this place, you can fill in what kind of library you are using, what kind of model you are training, what are the hyperparameters you are using for each model. Then in this way, your model can be tracked in the Git repository.
Right.
I definitely like the templates. It's something that perhaps if, it's like a Kaggle project or some type of an open source data analytics project, I think if there was like a filled out template that gave an example of here's someone that was successful that did an open source project using this template, that would be great as like a business case, especially for the business users that approach managing a data science project.
Exactly. So very valid, and we are working on that. Just watch that space. So some of the things we're working on is maybe like a full day or multi-day hands-on training, taking someone completely through it. Right now, a lot of the filled-in projects we have as proprietary information in there. So we just put this on GitHub this week, and the things we're going to add to it will be examples, like really filled-out examples end to end.
Yeah, I have two questions. The first one is, obviously, we don't have Azure, and I don't know when we are going to be going Azure.
Yeah.
So is there a possibility of having similar features in Team Foundation?
And so I think, so good question, right? We talked about this, and internally we've been talking a lot about how much do we tie this to TFS and everything else. We've tried to, by putting this on GitHub, we've tried to make this fairly independent of the exact tooling that you use. So you can go to GitHub and basically clone the repositories there, have access to all the templates, to all the utilities that are run, and run it completely on your own system for keeping track of work items. Okay. What we were demonstrating today is that we're using VSTS because it provides a lot of useful attributes. I think you can probably use the same in Team Foundation too.
Okay.
Or if you prefer to use another tracking version control system, you're free on that too.
And the second question is the principal component analysis that you were showing. So are you actually doing the Verimax transformations when you're clicking through it? Or is it something, it's just the visualization part of it?
No, it's actually exact projection to the lower dimension space. It's principal component. What you see on the screen is actually the loading on the principal component axis. Yeah.
Yeah, and just to emphasize as well, so what Hans showed us is this is like a built-in utility that we have. Essentially, it's R scripts using Shiny. It's also meant to illustrate this is a utility that you have access to, that you can expand on and basically provide to your teams to make sure that when they do data analysis, that it really scripts them through the process and helps them produce consistent analysis and a consistent report at the end of that, right? So you can customize whatever is appropriate for your problem.
Python is coming, by the way.
All right. Yeah.
For Python fans.
Okay. Anything else? That's done. Right. Well, thank you very much for your attention and.